Okay, hi grade eights. How's it going? I just want to do a quick introductory video before I really dive into helping you out through the guided examples. First of all, I'll say this is our new unit. We're analyzing the graphs of linear relations. It's a little bit related to what we've done already, and it's related to the very first unit we did when we talked about line graphs. A little bit, not a lot, but a little bit. Um, it can be, this unit is generally pretty visual. It's a little both of symbolic and visual. But let me just give you a quick sort of overview or introduction of what we're doing, okay? Our learning outcomes are, we're going to learn how real life situations can be represented using graphs, tables of values, and equations, okay? You did touch on this a little bit in grade 7, and I believe you even did a little bit of this in grade 6. For sure, you did patterns and relations using like T-charts, right? In grade 6. I know this because I've seen them outside Miss Draken's room sometimes when I walk down that hallway. So the other outcome is using graphs to help us understand how two variables relate to each other, okay? So it could be anything. It could be hours worked versus how much I get paid. It could be amount of rain versus how much a plant grows, or how much sunlight versus how much a plant will grow, right? We're talking about two variables that may or may not be dependent on each other. This is a little bit of science. So we're trying to relate two things, okay? The cost of renting something per hour, okay? Two concepts that we're relating. That's why we have tables of values. And the most common table of values, we relate an X to a Y. But of course, it can be any two things. It could be a C cost to a T time. I'm just saying we don't always have to use the letters X and Y to relate two things in math or science. Okay? So we're using graphs. I'm on number 2 here. We're using graphs to help us understand how two variables relate to each other. And then number 3, developing the skills to answer questions and fill in missing pieces of information or data. So in other words, this is what we would assess you on, right? Given the graph, can you tell us about what's happening at this point here, okay? So I'm just going to pause the video for a sec because I want to set up a couple of examples, and I'll be right back, okay? Okay, so I just wanted to, for the sake of being, I always like checking off lists. So we talked about this. Let's try that again, Mr. Swift. We talked about learning how real life situations could be represented using graphs, table of values, and equations. I briefly introduced using graphs to help us understand how two variables relate to each other. And we're going to develop the skills. We're going to learn how to be an analyst. We're going to look at the graphs. We're going to look at table of values. We're going to be able to answer questions based on that. Okay? So before we get started, actually, let me just go to this next slide. And I'm making a comparison here. I'm making, I don't know, I guess we call this an analogy in language arts. Do you remember in fractions, right? In our fractions unit, we're supposed to have the skills, right, to be able to convert fractions to decimals to percentages. So let me give you an example. Let's say I have this fraction, 1 over 2. Okay, let's just follow this green arrow. All right. And we're supposed to know, right, that 1 over 2 means 1 divided by 2, right? Or in other words, the decimal version of this is 0.5 or 5/10. So 1/2 is equal to 0.5, okay? So we have a fraction, and then we changed it to a decimal. And then over here, we take our decimal, again, kind of following this green arrow. We're supposed to be able to times it by 100 to convert it to a percentage, and we get 50%, okay? And we get 50, so this would equal 50%. Okay, so the fraction gives you the decimal, gives you the percent. All right, let me do maybe just one more example, okay? Let me use black here. Okay, so let's say I don't always have to start with a fraction. That was kind of what I was trying to get at here. Let's talk about, so let's call this example 2. So example number 2. Okay. Let's say I started out with the decimal of 0.25. Okay. And again, I'm trying to keep the examples relatively simple. Okay. So I'll just write it out here. I'm just going to repeat it here. So we're going to follow the red arrow this time, and we're going to go up and we're going to say, okay, this is 25 hundredths. So the fraction version of this is 25 over 100. But you are supposed to know about reducing or simplifying. If we simplify to lowest terms, we know that really we can change this thing into what? I was waiting there. 1/4. Okay, so I'll do it over here. So this time I started with the decimal, right? And the decimal we could get the fraction, right? So that's equal to 1/4. All right. It's very common or typical or understood that for most teachers and most times you should really try and simplify your fractions. Okay. No, I would not mark 25 over 100. That's not wrong. But if I told you directly in the question to simplify, you and I would be having a conversation. You see how angry I got there? Awesome, eh? Um, and of course, if you start with 0.25, you could retract yourself and go on the green arrow here, right? It doesn't matter. This is kind of my point here, and you could say it's also worth 25%. So yeah, you can go directly from fractions to percentages. Like this is part of the skill set that you get good at. The point is, and I'm going to make this my marker huge, and I'm going to change it to hot pink here, is you've got this sort of wheel of conversion that you're supposed to be able to go from fractions to percentages to decimals back to fractions, or you start with a fraction and you go to a decimal, or from a decimal to a percentage. You're supposed to get some skills and get relatively good at it. And in a similar fashion, the reason I mention this right now, and you're like, what does this got to do with equations, table of values, and graphs? Guess what, grade 8s? Do you see something similar here? Yes, you do. This kind of relationship in our current unit, our brand new unit, which by the way is going to go very quick. We're only going to spend 2 weeks on it. This kind of relationship also happens just like fractions, decimals, and percents. It's going to happen with equations, graphs, and table of values. So I'm going to put down this pen, and I'm going to grab an example here. So I wanted to start with the problem. Okay, so here we go. So I took this from the textbook, and this says, example 1, sound travels 1,500 meters in salt water. This relationship can be, I'm just going to switch this over here. This relationship can be expressed by the formula D is equal to 1,500T. Formula is the same thing as an equation. Okay, let me just get my yellow here. Formula, whoops, let me switch to pen. Formula is the same thing as an equation, okay? All right. And it says where D is equal to 1,500T, where D is, there's a variable, we're relating two things, is the distance traveled in meters, and T, okay, so T is the time in seconds. I did snip out sort of a blown up version of this equation. Let me share it with you. So, okay, so on one hand, you've got an equation to work with, okay? All right, so we're going to start with an equation. And then what you're supposed to do is that equation is going to give you a table of values. You can convert it to a table of values. I'm going to just shrink this a little bit so it fits a bit better. Okay, so let's look at the table of values for a second. The sound travels 1,500 meters per second. Sound travels pretty fast, nowhere near as fast as light, but it travels fast. At time 0, before we started measuring, let's just say it's the time before Mr. Smith started talking, silence. The sound can't travel anywhere at time 0. Now, after 1 second, as soon as I start talking, that sound, if I wasn't blocked by walls in my home, that sound would be 1,500 meters away after 1 second. And then after 2 seconds, 3,000 meters away. After 3 seconds, 4,500. So there's a relationship here between the time and the distance. The further the sound continues on in time, the further away in distance it goes. So 3, 4,500, 4, 6,000, After 5 seconds, 7,500 meters. After 6 seconds, we add another 1,500, right? Or it's 1,500 times t, right? These are going up by 1,500. You get 9,000 meters. So there's a pattern. There's a relationship. Every equation and formula will have a relationship, all right? And that relationship can be expressed in a table of values. Now, obviously, where am I going with this? Well, of course, if you have a relationship, you could plot it. You could put it on a graph, okay? And there it is, all right? Now, you can notice that if you can, I don't know if this is small on the on your video, but anyways, I've got a little bit of an issue, not too much though. I don't think that red dot is placed exactly correctly, but whatever. It should be a little bit down in my opinion. I'm just being picky. But look, at time 0, we have our ordered pairs, right? So just remember, we have ordered pairs. One of our ordered pairs is 0, 0. Let me just plot this out. Let me use blue. No, let me use purple. Okay. So look, these are points of data. Okay, another word for points of data is to say, what I'm circling here in purple, right? I'll just use the space. They're called, we know this from last year, hopefully. These are ordered pairs. They're plottable, right? They're plottable, which means they can be put on a graph. We can make a visual representation. So, actually, I'm just going to make room here. So your ordered pairs go like this. All right? The time, right? Time and then distance. So we can convert this table to plottable points, okay? Plottable points means we can plot them. We can put them on a graph. So 1, 1,500, right? 2, 3,000. Okay, I'm not going to write all of these out. You get the idea. 3, 4,500. Okay, some of you might think that's a 6. It's not, it's a 0. Okay, and so on and so on. 4, 6,000. So look what it, just so you know, you got to be very careful about your scale, because look what it says here. The distance in meters in thousands, it puts you in brackets here, in thousands. So this isn't 2 meters. This is meant to be 2,000 meters. It's just they didn't want to write all the zeros, right? Okay. So this point here, let's start with this point. This point here is your 0, 0. I'm just going to make my pen a little bit finer so it's not so thick. Okay, and then over here, right, this is where I can play. I think this should be more down here. Doesn't matter. This is 1, oh, look how fine that pen is. 1,500. Okay, and then over here is 2, 3,000. Okay, 3,000. Then over here is the ordered pair of 3. This should be 4,500. Oh, I'm wrong, by the way. I was wrong to say this point. Yeah, you're right. Sorry. See, look at this. Halfway through is 1. So halfway between the halfway. No, this point is correct. This point is correct. My God. Mr. Smith. Overthinking it. Bad Mr. Smith. Okay, and this point here, right, what's its location? Well, it's at the x coordinate or the t coordinate of 4, 6,000. Okay. All right. Look, that's basically all I want to do for an introduction, okay? I wanted to show you that similar to fractions, decimals, and percents, and you're converting this one to this one, and this one and this one, and that one and that one, and that one and that one. Do you like how I said that? You can start anywhere here. I could have started with a graph and then got the table of values and then got the equation. Any one of these can be a starting point, okay? Any one of these. Let me go back to hot pink, all right? You could, let me just get this a little bit thicker. You could start here. So this could be your start. And from the graph, you get the equation and you get the table of value, okay? Or, let me just switch again. What if I started you off with the table of values? Would it be possible to get an equation from it and get a graph? Yeah, we could. And then the last one, let's do black. Okay, what if I started you with the equation, like this example? If I started you with the equation, Could you get a graph? And could you get a table of values? And the answer is yes. So finally, I'll end this just by saying the emphasis of this particular unit is supposed to be about analyzing graphs, okay? All right. We'll try to focus on the visuals. Okay, grade 8s. That's enough of Mr. Smith introducing. And next few videos I'll get into, I'm going to walk you through like 4 examples, okay? So bear with me. I'll try to keep the video short, but this is an important concept, and I do want you to learn it and try and learn it well. Okay, see you later, guys. Have a good one. Thanks.